Hello. Hey, Marino.
Hey, how's it going, Peter? How's everyone doing today?
It's good. It's Tuesday. It's Tuesday, but it feels like it's Monday. But hopefully, after this hoot, it'll feel like it's Friday. But
I have no sense of time anymore. It's been quite a year.
yeah,
This is probably one of our last few hoots. I think you've got a couple more, right? Before the
yeah.
new year.
I'm planning. I'm planning to do another one in. Let me see, on the 19th, maybe. But I'm still thinking if we should do like year in review, or like instead of doing ask me anything, do like a ask us anything, and then have a couple of people more on the stream. But yeah, if anyone has any specific ideas, or wants us to talk about something like specifically, let us know. Say hi in the comments. I see there are a couple of people here, so we're always curious to talk to you all. But anyway, so Hoot 62, and the title is Understanding TLS Identity and Authentication and Authorization, right? In action. I got that right, yes?
100%. I actually should have updated the title, but that's really the gist of what we're covering today. TLS is widely used in a lot of different aspects of Kubernetes and our applications and services and Istio. And sometimes it's always good to just go back to the basics and understand how these things work and function and what that really means for us. So we'll dig into some more of this. I think you know us, right? You both, everyone here knows Peter and I. We are the platform advocates here at Solo, the beautiful
Yeah.
faces of Solo doing some wonderful things.
I stopped introducing myself after a while, because it's like it's every
Yeah.
2 weeks people see my face, hopefully, right, hear my voice. So at least I don't expect you to know my last name, but I would expect you to remember my first name at least. But
I agree. Yeah. So we'll cover some basics around the certificates, identity, Istio, AuthN, AuthZ. We'll just review some of that stuff, and then Peter will cover off some of the SPIFFE and SPIRE pieces that really play a huge key role in identity, especially when we're working with workloads in Kubernetes. And then we're going to dive into a hands-on environment that we'll make available to everyone at some point very soon. So y'all will have access to some of these basics as well, because I think it's important. And for a long time, working and understanding how certificates certificates inside of Istio, inside of Kubernetes works, how it all gets rotated, the different moving pieces, how Cert Manager and the Istio CSR come into play, like, was kind of just a whole bunch of spaghetti in my mind. And Peter really came in and provided some clearer context as to how all of these pieces fit together, and it's all showing up in that workshop or that lab that everyone will get access to. So let's dig in. All right, so piecing it all together, I had no title for this slide originally, and I felt like it was necessary to talk a little bit about Istio's role in all of this. So at a high level, Istio is a service mesh. It provides security, observability, and traffic management. We're focusing on security, and more specifically how Istio helps with the certificate issuances towards workloads that exist inside of a cluster, as well as rotates them, and how Envoy plays a huge piece of it. But we'll start off with the fact that there are three key components involved. We've got Istio-D, the control plane. We've got, which actually houses something called Citadel, which is the certificate authority inside of Istio-D. We've got the Istio agent, and we've got something called the Envoy proxy, which I think everyone knows. Now, Citadel, like I mentioned, is the CA and will sign and issue certificates to workloads inside of Kubernetes that we've tagged to be a part of the mesh. The Istio agent is a binary that runs inside of the sidecar, and it's responsible for requesting a certificate for the workload and then making sure that certificate and key is available to Envoy via something called the secret discovery service. The Istio agent is also responsible for ensuring that these certificates are rotated so they don't expire, making the workload not communicatable or we don't have access to the workload, or we can't make requests towards it. The Envoy proxy itself is what connects to the Istio agent to receive the certificate, and will effectively use that cert in communication towards other proxies or workloads. Now, there's this element of identity that comes into play here, because each one of those certificates houses the identity of a workload. So you have a specific format, and it is very resemblant of something we would see inside of a host name for a cluster. So we've got the cluster domain name, the namespace that it exists in, and then a particular service account. In our case, we're using the HTTP bin service account, because that's what we're creating a particular SPIFFE ID for. Now, this identity makes this particular workload unique, so it makes it very difficult or almost impossible to masquerade as that workload or pretend to be that workload. So for workloads in the mesh to use something like MTLS, we can enforce, and we can also use MTLS to enforce things like authentication policies. The identity comes into play here. But as I mentioned, SPIFFE ID is the key part here and what makes this all identity possible. Now, when it comes to certificates, and by the way, we'll dig into more of SPIFFE and SPIRE and how those two are interrelated as we get to some of the more advanced pieces here. But we have a few options for how we can issue certificates to workloads. So Istio-D uses some base certificate authority data to push it inside of config maps in namespaces. That base CA data can either come from the form of a certificate or CA cert secret. So when Istio-D starts, it looks for the CA cert secret and pushes that CA data from the secret to config maps. The other option is using something called a mesh config, where we can provide the CA certs directly, and then Istio-D will push those to the workload. So for example, we'll specify a cert versus Istio-D generating that cert. Mm-hmm. And now there are external CAs that come into play here. Now we'll actually investigate one, which is the cert manager. But the first one uses the Kubernetes CSR API. So CSR stands for Certificate Signing Request. And it's a resource inside of Kubernetes that is used to request certificates and sign them appropriately. In the case, or in Istio's case, we use Istio-D to act as that resource authority or that registration authority, which approves the request, as opposed to the CA that signs the certificates. So Istio-D will create and approve the CSR as well. And then Cert Manager, for example, will assign it. Cert Manager is configured using an issuer to sign the CSR. These issuers represent the actual certificate authorities, and there's actually a bunch of good options that we can pick from. We've got Google, CAS, AWS, Private CA, and so many others that exist out there. The benefit here with these two options is that the private key is not present in a secret inside of the cluster. Instead, it's actually stored outside. Like, for example, you might be storing some of these secrets in Vault instead.
Yeah.
So the last tool is the Istio CSR, which is another project that you can run inside of your cluster. And it uses the certificate request form from the cert manager itself to request certificates. And in this case, Istio CSR acts as a registration authority, whereas cert manager acts as the CA. The flow is very similar, with one key difference. The workloads in the cluster talk directly to Istio CSR, not Istio-D anymore.
Yeah. But in the end, the idea is, like, from that first one, when Istio uses the self-signed CA, right, by default, that's what you get by default. All the other options are just a way to you can either replace the self-signed CA by yourself with the mesh config, but the other two options are just to use other tools to externalize those things, so you don't have to worry about them, right? So you have, like, cert manager is gonna call out wherever it needs to call out, and it hooks it up. Like, and this diagram describes this better than I will ever be able to talk about it. But
Well, it's funny because you're the one that created this diagram,
Yeah,
right?
yeah. But I know. But what I was trying to say is, it's like all those three things are basically, the key is that the CA cert, right? And how does that cert get into the cluster, right? And who talks to whom in order to issue the workload certificates. That's pretty much it, right? The flow is the same in the end. It's just different components will be involved, right?
Exactly. Yeah. So in this particular scenario, we're using Cert Manager and Istio CSR, but we'll be using a self-signed cert scenario as well, and we'll use Cert Manager as the issuer. In this case, we're using Cert Manager. We create a self-signed issuer first, and then we request a certificate and that certificate drops the files into a secret. From the previous scenarios, we know that we need to provide the root CA to IstioD. We've done that previously by creating a CA cert secret, or effectively just letting IstioD
Istio
create
do it.
that.
Yeah, yeah.
Yeah, that self-signed CA. This time we'll create a secret that Istio CSR will mount at step 3. So if you take a look at step 3, where it actually reflects the ca.pem, is effectively where we're going to create another issuer called Istio CA, and then that happens at step 4. This issuer points to the Istio CA secret and is referenced by a cert manager. So whenever a workload certificate is needed, cert manager will use this CA issuer to create the certificate. So we can go ahead and start Istio CSR. That goes to mount the root CA. And finally, we install IstioD that turns off the CA serve functionality and points to Istio CSR as the one that serves the certs instead.
Yeah.
So now when workloads need certificates, they talk directly to Istio CSR.
Yeah. So you're basically like, yeah, IstioD could do all this, and it does it with the self-signed certs, right? But now you've externalized this concern into the CSR that hooks up with Cert Manager, and then Cert Manager, if you used it before, it's fairly straightforward to create like different issuers, maybe if you want to. You definitely don't want to use a self-signed issuer, right? And you can hook it up to different, like you can hook it up to what's the Azure, not Azure, AWS services. I don't know what the Google CAS, AWS, like private CA or whatever those things are, like managed services for certs, right? But yeah, it's just a way to do whatever Istio can do, but externalize it with these other tools so you can do it in a more production ready kind of way, I guess.
Exactly. Yeah. And I think that's the whole point. Like this exercise and the workshop itself really paints a picture of like how you would want to do this in production, because you don't want to be doing just manual cert issuances or anything of that nature. And now we also want to think about things around authentication and authorization. So when you have workloads that have been issued certs, you now have this ability to decide if you want to upgrade your connection between workloads and ensure there is some encryption in place, and ensure that workloads that have certificates are able to talk to each other. So that's offered up through something called the Peer Authentication Custom Resource. And you could actually set up a few different modes. There's permissive, which means that you could have connections between workloads that have a certificate and workloads that don't. You could force a connection. So meaning like if you've got the strict mode set up, both ends of that connection need to have that certificate. Otherwise, the connection won't occur. Or you could disable it altogether so that there isn't a requirement for the cert. But in the permissive mode, interestingly enough, if both ends do have that certificate, that connection gets upgraded to have MTLS available. Now, the other side to this is, okay, you could use this as a mechanism to prevent unnecessary communication, but that's part of it. Like, okay, sure, if you set it to strict, now you expect all of your workloads to have that certificate, and non-certed workloads or non-sidecard workloads, for that matter, won't be able to connect. Cool. But within the base of workloads that do have the sidecar and the certificate, now they've got free reign to be able to do whatever. And one thing that you want to consider now is enforcing authorization. And authorization is effectively, what am I allowed to do to this other object? What can I do to this other object? And it comes in the form of an authorization policy custom resource that Istio offers up. So you can set up rules that basically dictate the source of that request and the direction of where it's going towards the destination. And then you can decide whether you're going to allow or deny those requests, and specifically what those requests are. They could be specific get operations, delete operations, patch operations within the HTTP space. So this is a mechanism to allow us to just enforce some access control, so we don't have resources communicating and reading or modifying resources unnecessarily. Peter, do you want me to stop sharing and you could share your screen for?
Yes. Yeah.
Okay.
Let's do that. Let me
so we're gonna move into
windows.
So we're gonna move into the next section around SPIRE and SPIFFE, and then we will kick up a lab environment for y'all.
Let me just find my windows first. If there's if anyone has any questions, this would be a perfect time for you to ask.
Exactly.
while I'm trying to share the screen here. I think this one will be fine, right?
Yep.
Good. Yeah, perfect. Yeah. So one thing that I want to just add here is, so you have to have both authentication and authorization, right? Authentication tells you who you are, and authorization tells you what that authenticated principal can do, right, or not do, right? If you have one without the other, that's not going to work, because you're not solving anything, right? Like you can tell people who you are, right? You can be whatever you want to be, but if you don't have the authorization and you're not you're allowed to do anything, you're not really solving anything there, right? And the other thing that I think, as we go through the labs, the demos, I think we mentioned it there somewhere, is that the peer authentication resource, as Marino said, controls the communication between services, whether the connection is permissive, strict, disabled, right, etc. And there's also the request authentication resource. And that one is for requests, for users, let's say, right? So peer authentication, peers are services in this case, and then request authentication is for users, if you want to authenticate different users. Now, both of those things, then if the authentication is successful, you get a authenticated principal out of it, right? In the case of the peer authentication, the authenticated principal is a service. In case of the request authentication, the authenticated principal is the user and its claims, right? The claims and JOT token, right? And then you can use those in the authorization resource. Anyway, all right, let's do just briefly on SPIRE. So what SPIRE is? So SPIRE is a production-ready implementation of SPIFFE APIs that perform node and workload attestation to issue SVITs to workloads and verify SVITs of other workloads based on some conditions. So what this is just saying is issuing SVITs. So SVITs are SPIFFE verified. Let me see. I always forget what this is, but it's basically an X509 certificate.
Yeah, SPIFFE verifiable ID.
Verifiable ID. Yeah.
Identification document.
It's a document. Think of it as a file, right? SVIT in Istio's case, it's an X509 certificate, right? And that X509 certificate has the SPIFFE ID, that string that Marino showed in slide 1 or slide 2. It has that encoded in a subject alternate name field of that certificate. So that's a decision that's specified by the SPIFFE spec, right? So SPIFFE spec is saying, hey, encode this here, and then Envoy proxy knows how to check for that URI. So SPIRE is just an implementation of the SPIFFE APIs. Istio is another implementation of a SPIFFE API, right? So let's look at the SPIFFE first. I think I've basically talked through this right now, but SPIFFE ID, string that uniquely identifies a workload, cluster, a local namespace, and then service name, service account name. SVID, SPIFFE verifiable identity document. So that's the certificate in this case. And then there's a workload API that's used by the workloads in order to get the identities, right? So at a high level, what SPIFFE defines is how services get identified using this unique string, this SPIFFE ID, how this SPIFFE IDs get encoded into the SVID document. So these documents, as I mentioned, are either X509 certs or JOT tokens. And these are then used by workloads to provide their identity to the caller. And then lastly, how these SVIDs can be issued. And this is what the workload API specifies. So different components of SPIRE. So there's the SPIRE server, and there are the SPIRE, one or more SPIRE agents that run on different nodes. So both components have an API that they expose. On the server side, there's the registration API, and this one is used for automatically or manually registering workloads through something called registration entries. And then the node API is the one that it's used by the agents to talk to the server. Now, on the agent side, there's the workload API, and this is what the workloads use to talk to the agent to obtain their SVIDs, to obtain those certs. So the SPIRE server is going to act as a sign-in authority for identities, and it's going to issue those identities to SPIRE agents through the agents to the workloads that that are connected to the SPIRE agent. Now, the service is also configured with a specific trust domain, and that trust domain that becomes part of the SPIFFE ID. So in this example, we have example.org. By default, the server generates a self-signed certificate, of course, and then uses that to sign the SVIDs for the workloads. But there are numerous different plugins. The one for the CA specifically is the upstream authority, where you can say, here are my CA credentials, and I want you to use those certs in order to sign the workload certs. And I mentioned the plugins. So plugins are just a way to extend SPIRE server or tell SPIRE server to use a different way to either use a different persistent storage, different signing key and storage logic, and so on. So let's talk about node attestation. So what happens with node attestation is that SPIRE server and the SPIRE agents are going to work together to verify the identity of the node that the workload is running on. And the way to do that is by using node attester. So there's a node attester plugin in AWS, for example, right? And that AWS node attester plugin knows how to query AWS to get back the proof of the node's identity. So the SPIRE agent is going to make a call to AWS, right? And is going to get back the proof of the node's identity. Now, I'm talking about AWS here, but there's other node attester plugins for Azure, GCP, Kubernetes, and so on, right? So what's gonna once that happens, the agent is gonna send that gathered proof of identity to the SPIRE server, and there's another node attester on the SPIRE server side that's gonna independently validate that identity that was sent by the SPIRE agent. And then once the identity is validated, it's gonna create a SPIFFE ID, and it's gonna send that SPIFFE ID back to the agent, and then the agent will use the issued X509 to talk to the server through mutual TLS, right? So this is just SPIRE agent is saying, hey, give me the information of the node, right, that I'm running on. It sends that to the SPIRE server. SPIRE independently verifies the same thing, makes the same call. And if that matches, the SPIRE server issues a certificate that the agents can use to talk to the server. So how does this work in Istio? So when you're running workloads in the mesh, right, most of them are deployed as Kubernetes pods. And then within that pod, there are two containers. You have the app, typically two containers, at least two. app container and the sidecar proxy. And now if we go deeper here, and there was another image that we had diagram earlier that showed this in a different way, I guess. So the sidecar proxy, the Istio proxy container that runs in the pod is actually made out of Envoy proxy and a binary called Istio agent. So the Istio agent is the thing that actually starts up and it bootstraps the Envoy proxy and launches it. And it's also the one that's provisioning the identities for the workloads. So how does that work? So Envoy uses something called Secret Discovery Service, SDS, to talk to the Istio agent to retrieve the certificates. So the Istio agent, when it starts, is going to create a private key and a CSR, and it's going to send that to IstioD, to the control plane for signing. IstioD will validate the credential and send the signed certificate back to the Istio agent. Then the Istio agent, because it acts as an SDS server, and that's mounted on the Unix domain socket. We'll see this in the lab. And that socket address is well known to Envoy as well. So Envoy connects to that one, right? And that this is where the Envoy receives the certificates that it needs to use to to present them when talking to other services. So this Istio agent is then also responsible for managing the life cycle of the certificate, and it'll rotate the certificate before it expires. Now, by default, when you deploy Istio, right, when you inject a sidecar, if you will, right, Istio agent will start an SDS server, right? However, there's a logic in the Istio agent that checks whether that socket already exists. So if the socket doesn't exist, Istio agent will start the server. However, if the socket is already there and it's responsive, it's not going to start an SDS server, which means that instead of connecting to the Istio agent's SDS server, Envoy can talk through the same socket, right, to something that implements that SDS API. And that something is the SPIRE agent, right? So this diagram looks very, very similar. Envoy is still going to talk through that socket to SDS, right? However, this time the implementation is going to be on the SPIRE agent side and not on the Istio agent side. So once connected, then the SPIRE will be able to stream back the certificates to the Envoy proxy. So just like Istio agent was doing it, this time, this time the SPIRE agent is doing the same. So it's not Istio agent, it's not going through IstioD anymore. It's going through the SPIRE agent, and the SPIRE agent is going to talk to the server, and etc. Here, this is how it looks like in Kubernetes. It's fairly straightforward, I guess. So there's the SPIRE server, there's multiple SPIRE agents, one agent per node. Workloads are modified, and we'll show this, to connect to the SPIRE agents, and then the SPIRE agents are connected to the SPIRE server where they go and issue certificates. And there's also a SPIRE controller manager. I would have to double check. I know there's been some changes in SPIRE. If this is still the case, that it registers the workloads in the cluster automatically, right? So then you can actually issue the certificates for them. Yeah, so I think this was the last slide. I hope, Marino, you have the lab started up. I'm gonna.
Yeah, I do have the lab started up.
And I see there's a question.
Mm-hmm.
Let me see. So Istio CSR issues only the root CA, and Citadel mints workload certs by signing it with the issued root CA, or all the cert requests are proc. So let me go back to the image, the one that we let me actually share it, so it's gonna be easier. Share it back again. This one, right? I think it was this one. Yes. Yeah, I think it was, right? Yeah. So the question is, so Istio CSR issues only the root CA. So Istio CSR doesn't issue anything. It issues the workload certificates, right? So it's connected So we create a self-signed issuer, and the cert manager creates a certificate using that self-signed issuer, a CA certificate. And then we use that as for the Istio's root CA that's mounted into Istio CSR. And we create another issuer called Istio CA, and then Istio CSR is the one that uses that Istio CA to mint the certificates for the workloads. I hope that answers the questions. So let me see again. Issues only the roots. Yeah, so there's no root CA issued by the CSR. So CSR uses Istio CA issuer to mint the workload certificates. Yeah. So it signs with the issued root certificate that was issued by the cert manager. Hopefully that answers it. All right, Marino.
Yeah, I've got my environment up, but I thought you were going to start off with.
I'm the next. Oh, sorry.
Yes, with the identity in Istio.
Yeah. Sorry, I didn't mean to. Let me just find my screen. Might take me a minute to.
But that's okay.
This, but it's fine. If I'll share it while it's minute 30 seconds. So either someone tells a joke or someone asks a question or something. But
last minute jokes.
We have a minute of time while this starts up. I totally forgot that it was my turn first.
So what did the IPv4 address do the moment it walked into the bar?
That's a too networky joke for me. I'm not gonna.
It said, "Give me a cider, bartender. I'm exhausted."
Oh, okay. Haha. Yeah. We don't have the. This would be the perfect time to play a sound or something, but we don't have it.
I'm so sorry, everyone.
This would be a perfect time to play.
You wanted a joke.
I know. Next time I'll be more specific, and I'll say when it wanted a good joke. But anyway, well, someone's laughing. All right, so it's not just. All right, so I guess the joke was good.
Okay, I'll give you one more. I'll give you one more. An IPv6 address walks into a bar. Nobody wants to talk to it.
Okay, where's the punchline?
No one wants to do IPv6.
I know.
Okay, that wasn't as good. I'm so sorry.
Yeah, perfect timing. Look at that. It started.
Okay, I'll stop.
No, but all right. So this first one was just I think we talked about this. I'm not gonna read through this again. So Istio does use X509 certs across the different components. I hope this is readable. Let me see if I can make it maybe like this. Feel free to yell if it's not if the font is not big enough. But yeah, I was just talking this thing X509 workload certificates, right? X509 certs, right? They're there to perform mutual TLS. It's called Citadel. It runs as part of the ISTIOD and acts as a certificate authority by default, right? We've seen how that can be replaced by Istio CSR, Cert Manager, and then also with SPIRE, right? And this is the same root of trust. This is just talking about different places where certificates are. The other place that I want to mention, we haven't mentioned it yet, is typically you also have a certificate on an Ingress gateway, right? The TLS certificate. And that's something that's typically managed with like Cert Manager, I guess. All right, let's click next. Hopefully this will go fast now, and then we can go into some, not going to say code, but some YAML at least, and some examples. There we go. Identity. So we talked about SPIFFE. So let me do this. This is the thing that we talked about as well. I think this is the image that you had in your slide, right?
Yeah, right at the beginning where I was just talking about how Istio and the Istio agent actually is issuing the certificates and capturing that.
Yeah. Yeah. So it signs issues a CSR to STOD. STOD acts as a CA, sends back the signed cert, and then STO agent streams that to Envoy. But we've seen that it uses the SDS, STO agent does, but we've seen how we can circumvent, I guess, STOD in a way, and Envoy can still use the same SDS interface, but in that case, it's not talking to STOD anymore, or sorry, to STO agent is going to talk to SPIRE agent in that case, right? All right, so the first one we're going to do STO and Cert Manager and then STO CSR. So I'll just install Cert Manager here, just a Helm chart, adding the repo, updating it, and just calling install Cert Manager, specific namespace, the version. I think this is the latest one that's out there that I was able to find. And then once this is done, we'll be able to see the CA injector, the Cert Manager, and the webhook deployed into the Cert Manager manager namespace. Should be. I don't think there's enough time for another joke, so I'm not gonna. There you go. Perfect timing. No time for jokes. There you go. So let's list just three pods running there. And then what we're doing here now is I'm just going through those steps that we had in that complex diagram, I guess, with like 6 steps. And what we do first is we'll create a certificate issuer that's going to tell Cert Manager how to issue certificates. And we're just going to use a self-signed CA here. But this could be something where you plug in like one of the cloud providers managed service if you want, right? So we're creating the issuer, just a self-signed issuer. There's not many settings here. If this was a proper non-self-signed issuer, you would have more things here to point to whatever service is going to do cert issuance. So once we have that, then we're going to request a self-signed certificate. And the way we do that is we'll create the certificate resource, and we'll use this certificate as the root certificate for the CA for STO. So this is how this looks like. This is all Cert Manager, right? Just creating the CA cert, telling Cert Manager to drop the certificate into the STO CA secret, specifying the private key, setting the subject, and then just referencing that self-signed issuer we created 30 seconds ago. Let's do this. So now what we can do is we can list the certificate resources in STO system, and we'll see that we have the STO CA certificate is ready, and there's a secret called STO CA that contains the certificate and the key. You can look at this here. Whoops. So secret, describing the secret, just some annotations, and we have a key, the certificate, and the CA certificate. Right. So what we'll do now is we'll extract this CA cert and create another secret that only contains the CA cert. Right. So this is what this command does. So it uses, let me copy it here again. So get secret, STO CA from the STO system, and then we use JSON path to say, get me the contents of the tsl.crt, and then base decode it into the ca.pem file. And what we're doing is then, once we have that ca.pem, we're going to create another secret called STO root CA from this specific file. Okay, so what will happen with this STO root CA? This is what STO CSR will use to issue workload certificates, right? Lastly, we will create another issuer that will use this CA cert to issue the certificates, and this is what the CSR will use at the end, right? So just an issuer, it's pointing to that STO CA secret that we created, right? And this is what STO CSR is going to use. Now, all these steps with the self-sign thing, if you already have your own CA certificate, you would probably continue from here, right? You don't have to do all that self-sign thing there if you don't want to, right? This is just to show you the whole flow. It's almost like we're using Cert Manager to bootstrap a lot of things. what we could have done is just created a CA PEM file locally, right? And then just continued from this step. But, okay, so we have everything in place now that we can go and deploy Istio CSR. So Istio CSR works together with the cert manager in order to issue the certificates to the workloads. So instead of using the Istio D, we'll use Istio CSR to issue that certificate. I'm going to use Helm again and set a couple of, set the root CA file. Well, let's read it this way. We're going to mount the secrets, create a volume, right? Mount that root CA, the Istio root CA secret file from that secret that we created under this path, and then we're just setting the root CA file for the Istio CSR. So if we run this again, we'll see the Istio Cert Manager Istio CSR is up and running, and now we can go and install Istio. And this is where we'll basically tell Istio to use that root CA for the Istio D deployment. And we're disabling the CA server functionality because we want to use Istio CR. And then this one is just mounting the certificate from the cert manager, right? CA root cert from there. So this is what you would typically do. Ignore this error. Yes, we're using a Kubernetes version that's not supported by the latest Istio, but it all works. We've tested it out, so you shouldn't be doing this, but we're just doing it for the demo. All right, so what we're doing is just installing Istio, and we modified the pilot configuration a little bit to disable the CA server, and then to modify the Istio D deployment by basically pointing to the cert manager certs instead of the ones that Istio would be using otherwise. So we have this, and now from this point on, we can just go and try it out. So we'll label the default namespace with Istio injection, and I'm going to deploy HTTP bin. And then once this is running, it's going to take a second or two. What we'll do then is I'll use proxy config secret command to get the certificate and then decode it just so we can see that it's coming from the cert manager or it's being signed by the CSR. All right, so it's up and running. And we'll use proxy config secret on the deploy HTTP bin. We want to get JSON, and then we're using JQ to extract the secret TLS certificate bytes, and then decode base64, decode it into the workload cert.pem file. So we have this file here. And then we can use the OpenSSL to get the text representation of the certificate. And you'll notice that the issuer here is cert manager. Right? So this is just telling, and then down here, there's that SPIFFE ID. But this is just telling you it's not IstioD who's issuing workload certificates. It's Istio CSR together with the cert manager doing that. All right, so let's click next. I think, Marino, do you want to take the next one?
Yep, I can swap over.
There we go.
Just going to present my... Where are you hiding? Here we go. Nice. Okay. So we're gonna just explore some other areas now, the other layers of security that become very important, and it's authentication and authorization. We talked at great length around what they can do. Authentication is really about verifying the identity of a principal, and the principal can either be a user or a service. So for example, if you log in to a website with some credentials, username, password, maybe some MFA, you're actually an authenticated principal at that point, which now gives you the ability to do things, but obviously there might be some additional policies that prevent you from doing certain things. So this mechanism here is like, when we think of Istio and the way authentication works here, is that we have to authenticate and validate the identity of each service, of each end of that service. So some services may present an identity document, some services might not. And so we have to tune our mesh that way accordingly. There might be situations where you're actually starting to slowly onboard services into a mesh. And so the wrong move to do would be to go MTLS strict right off the gate, because you don't really allow yourself an onboarding path for your non-mesh services to be able to communicate with your meshed resources. So that might be a consideration. So anyways, when it comes to authentication, we have 3 modes of it. There's the permissive mode where MTLS isn't required, but if a service is presenting a valid certificate, it will be used for authentication and upgrade the connection to MTLS. If the configuration for peer authentication is strict, then MTLS is required for all connections in the mesh. And if a service doesn't present any sort of certificate or a valid one for that matter, the connection is terminated. And then with the disabled flag or the disabled configuration, no MTLS is required, or MTLS isn't used for authentication and certificates aren't required. So what we're going to do is we're going to create a new namespace called HTTP bin, and we're actually going to label that namespace with the istio-injection equals enabled. So sidecars are going to be launched once the applications have been deployed or the workloads have been deployed. We're going to create another namespace called sleep-ns and deploy a sample app there where we're not going to tag the namespace or label the namespace for sidecar injection. And so once these 2 have been fully deployed, we can do a kubectl get po-n sleep-ns. And then we could also do a kubectl get po-n. Oh, I don't need the plus sign there. I need an NN.
You could and see what happens.
They'll probably just scream at me. I don't know.
Maybe it'll tell you a joke.
Bad one, like I've been telling. HTTP bin-ns.
Oh no, don't leave it there. It's gonna fail.
Yeah, I figured. That's okay. So anyways, I'll get the output of both. And we can see that in the sleep-ns, I've only got 1 out of 1 containers running, meaning no sidecar. But the HTTP bin, we do have sidecars running. So if we run this exec command, which effectively allows us to run a curl from the sleep pod directly to the HTTP bin, it actually should go through fine, because at this point, MTLS is by default set to permissive. So we'll see the request go through successfully. But if we modify and actually set up a peer authentication policy, because we actually don't have one. If we do a kubectl get peer, oh, okay, so it does autocomplete. There's nothing. And if I do a -a, nothing. So there is no peer authentication, and by default, it's going to be permissive. So let's go ahead and apply the strict policy here. And so by doing so, the sidecar resource just simply won't be able to communicate with the sidecarless resource. Actually, vice versa. The sidecarless resource. Yeah, the sidecarless resource, no certificate. It doesn't present. It doesn't present the other end with one, and so therefore it's not going to be able to communicate. And there we go, connection reset by peer. Now we could definitely deploy a sidecar for sleep, but we would have to re-roll out the deployment and redeploy sleep altogether to get that sidecar launched. But we're not going to do that. We're just going to delete the peer auth config, and we're going to set up some authorization now. So there's some bits about authorization that are covered up here. If you want to read read more about it, I think Peter went into some great detail about the principles and the source and destination and the flow of policies. But authorization simply is just to lock down what your services can do to other services. So let's go ahead and we're going to deploy another sleep workload into the HTTP bin namespace and just verify that it exists.
Yeah, so this is just to have two workloads, both with the sidecars.
Sidecar, exactly. Yeah. And just testing that functionality still works. We don't have the the peer auth policy right now in effect, so it doesn't really matter here. I think
I mean, we could, if you
yeah.
wanted to apply
Oh,
the strict one, we could, but it's not going to make any difference, right? Because
exactly.
they're both sidecars anyway, and they're going to do mutual TLS anyway, right?
Yeah, let's just be dangerous and do it anyways and see what happens.
Yeah,
Okay.
it should work.
Yeah, so it should work. And then if I hold on, I do have a curl command somewhere down here. So there's a curl command here, and it should function just fine.
Yeah,
Then
there's
yeah,
no, yeah.
yeah. So we actually have a layered approach here for defense in depth. We've got the pure auth, making sure that all of our workloads do have a certificate issued by SDOD. And then we're going to proceed to deploy an auth policy now. Now, this auth policy right here, because we haven't specified any sort of rules, effectively just means that this is a deny all policy, like a simple denial policy. There are other ways to write the denial policy, but I think this one just simply means that even if you specify the action of allow, if you haven't specified who's going to be talking to who, then it'll by default.
Yeah, you're basically saying, hey, allow this for these rules, but then you're not specifying any rules.
Like what? Yeah. So you have to start adding those exceptions
Yeah.
to say this principal can talk to that destination. So we're witnessing that. So we're going to go ahead and update that. We're going to add a new policy called allow get headers. Let's just quickly look at the policy here. So it's going into the HTTP bin namespace, and it's actually looking for workloads that have app equals HTTP bin. The action here is going to be allow. So meaning any traffic directed towards HTTP bin, we're going to allow it, but it must be coming from this service account sleep. And the only operation we can run is get. And the only place we can run that operation is on headers. So there are actually 3 conditions here. So in order to communicate with HTTP bin, we're only allowed to run the get command or the get request against this headers path. And it can only come from the sleep service account. So if there's another pod out there that is still attempting to do a get request against that headers path, it's not going to work. It's going to fail.
Well, not just get request.
Other
right, because
anything,
we have the
yeah.
allow nothing in force.
Exactly.
Yeah.
Exactly. So, if you are a network person, if you think firewalls, if you have your implicit denial at the bottom and then you start adding your allow policies are very restrictive, only allowing a certain direction of traffic. Anything else gets flagged and blocked and rejected by default. And this is very much how we're operating with the auth policies. So having applied that, let's go ahead and just do a quick test. And yeah, I mean, sure, the example says it works, but we want to make sure that it works. And it does cleanly. That's beautiful. Now, if we try from the another workload, and we actually no from the same workload, and we run
just /IP, right? You're doing
/IP, yeah.
/IP, different path.
Different path. It does not work at all. So
there's the same thing. If you would like have another like workload running, it's not going to work.
Exactly. So it's beautiful how the auth policies work. They're very granular, but shameless plug. We do this at scale with Glue Platform and Glue Mesh. So, All right, over to you to do that last one there, Peter.
Yep. Sure. It's. I just make it. I think this looks better, right? Hopefully, it's gonna start soon. But yeah, it's the key with the authorization policy in the previous demo or lab was that we had the allow nothing policy deployed first. So you're just you're saying no one can communicate, and then you're poking holes, right, and saying, oh yeah, you can talk to this thing on this path on this whatever using this method. That way you're selectively picking which workloads can talk to which workloads. All right, so this is the last one. SPIRE. I think a lot of SPIFFE and SPIRE. This is a lot of the repeat that we did in the slides, I guess. Yeah, this is actually a better image than the one we have in the slides. Yeah. Yeah, I think the difference here is that with the back when I was creating this slide, the change from the previous version of SPIRE was that you could actually define a SPIFFE ID template as well, where you could say, hey, this is how I want my SPIFFE IDs to look like. Like we know for Istio, it has to be this, right? However, you could theoretically come up with your own SPIFFE IDs and insert whatever you want into that string. But then you would have to make sure that your proxies or your workloads are actually know how to parse this and how to read it to say that it's to determine the identity. All right, attestation. This is another. I don't think we have this in a slide. So I talked about node attestation. There's also workload attestation, where we're trying to identify the workload. So the way this works is that when the workload starts up, it's going to send a request to the workload API to say, hey, give me my identity, right? And then the agent is going to take things like process ID and bunch of other like metadata that it knows about the workload. And it's going to pass it to one or more workload attesters. And then these attesters will determine the properties of the process that's calling the workload API, and then they're going to return the information they discovered in a form of selectors, right? And then selectors will have things like node name, namespace name, pod ID, container ID, and a bunch of other things that you could extract with these attesters. And then this is going to get compared. The data from the attesters is going to get compared with the data from the registration entries, and these registration entries are coming from the server, right? So server is going to discover the workloads, is going to say, here are the things that I've discovered, and the two are going to be compared here, and if they match, that's the identity that, well, the one that matches, that's the identity that the workload is going to get issued, right? Yeah, so it takes the selectors, compare them to the registration entries, and if they match, then the corresponding SVID is going to get returned from the workload. So if I don't know how, this makes it easier to read maybe. So look at these selectors here, right? So one of the selectors is the namespace. The other one is the pod ID, the node name as well, right? And this is the registration entry, and this is the SPIFFE entry that's associated with these three selectors, right? So this is the identity that gets issued to the workload. All right, so SPIRE and Istio. I think this is the same from the slides, right? SDS as being run by the Istio agent, and then SDS as being run by the SPIRE agent. So that's the difference. Who issues the certificates? From the Envoy side, Envoy doesn't care. It's just calling to that socket, right? All right, so let's deploy SPIRE. So note that this is adapted from istio.io. There's like a SPIRE quick start demo there, or task. If you want to go through it there as well if you want to. So what this one does, it'll install SPIRE server and it'll install SPIRE agent, but it might take a couple of minutes. So let's wait for this to finish. Yeah, this will come back. There you go. So we have SPIRE agent, single instance, and we have, SPIRE server, one instance of it, and then we have SPIRE agents running as well. Next thing that we'll do is we'll define a SPIFFE ID template. And this is the one that I had on the image there, is we're basically saying, hey, here's how I want my SPIFFE IDs to look like. So trust domain, that's cluster.local, namespace name, service account, and then the pod service account name. And we have the SPIRE managed identity set to true. So these are the match labels. And this is something that we'll set on our deployments to basically tell SPIRE, hey, this is the template that's going to be issued to the workloads with this label. So let's apply this one. It's created. So we applied that. Now we can go and install Istio. So let me see if I can show how this looks like. It's not the same deployment. It's modified a little bit. So it's setting the trust domain to example.org. And then we're creating a sidecar injector template called SPIRE. And what we're doing there is we're just mounting this this workload socket, right, using the CSI driver, right? So this is the whole don't mount the one from the Istio agent, don't use the one, don't run the one for the SDS from the Istio agent. Yeah. And then Ingress Gateway, we're mounting it explicitly, this workload socket there. And then we also have an init container just so it waits for the SPIRE socket to be up and ready. So let's deploy this one. This is just deploying Istio. So Amim is asking if we tried an external SPIRE server with ambient, any workaround? I suspect the webhook. Yeah, I haven't tried it, so I can't speak to that. Yeah, I'm not familiar with what would the issue there be necessarily, but I wouldn't be surprised if there is one, to be honest. If you did something, we had a meme on Hoot. Maybe a meme you figure it out and you come up on one of the future Hoots. Okay, so we have Istio. So because I used the demo Istio installation, disregard the cert manager. This was left over from before. There you go. So Istio Ingress Gateway, right? I have it running. So what we'll do is I'll grab the SVID, the cert from the Istio Ingress pod, and then we're going to save it into chain.pem file, and then we'll decode it. And you'll notice that the SPIFFE ID, I know this is the same as it was like before. Like this is what you would see before anyway. But notice the trust is example.org. And this is what we defined in the SPIRE deployment. So now if we look at the SPIRE agent, and which is grep for X509 SVID, you'll notice that the SPIRE agent was renewing the X509 SVID for this SPIFFE ID, which is the Istio Ingress Gateway service account, right? So the SPIRE, so Istio, the Ingress Gateway, when it launched, it talked to the SPIRE agent in order to obtain the certificate. So we can also deploy sleep. Oh, let me see. I messed something up. Let me actually look at it, show you what the difference is here. Notice the label that we added. So SPIRE managed identity. So we're saying, hey, use SPIRE to issue the identity here. And then we're also annotating it with the SPIRE template that we deployed. This is the one that does the workload socket, right? So let's do that. Let's deploy this one. Go. And then if we do the same as before, extract the certificate for sleep. And then if we inspect it, also notice the example.org, right? And then if we look at this guy, we should see, there you go. So now we have the Istio Ingress Gateway, but then we also have the default SA sleep that was being renewed or issued by the SPIRE agent. So yeah, I think that was the last one. Let me just double check in case Marino added some stuff. No, okay.
Nope.
All right. Yeah, so I think this was a pretty in-depth overview of a lot of things. I think we had a lot of other labs as well. Like rotating the certs was the one that I remember that we didn't include because it was just felt like it was too much.
Yeah.
A lot of things there, but yeah.
I think, it's very important to kind of get these basics locked down, only because it's not like people are going to move away from using service mesh technologies or other technologies. Like it's just going to be more and more consumed. And I think if we can demystify this more and more for folks, it will really go a long way, in my opinion.
Yeah. Yeah. And a lot of these things, I'm just trying to find I know I did hoots on some of these topics where I go into, like, I know SPIFFE SPIRE definitely did one on that, in case people are interested in like diving deeper into one specific thing. Let me see if I can find the links maybe. So this was the one for rotating the certs. So rotating the certs in STL, just pasting it in there. And there's more. There was a Spire one that I can't seem to find, but anyway, I'll find it and we'll post it somewhere. But I know there was there was a Spire one that I did. Oh, there you go. Overview. It was 9 months ago. Yeah, there you go. And in these, I go into more details about these different things there. So, yeah, are there any questions? Now would be the good time for anyone to speak up if they have any questions, or questions around this, or questions around anything else that we can help with. We can have Marino tell us one last joke while we're waiting.
I don't know about that. I'm kind of I'm tapped out of jokes at the moment.
All right. Well, I'm waiting for, like, let's wait another 30 seconds because I know there's a delay.
Yeah.
And I don't want to say, does anyone have any questions, and then just stop the stream for someone just to type in right when I click end stream.
Yeah.
No. All right. Going once, going twice. I think we're done, right?
Take care, everyone. Thanks for coming by to this hoot. We'll see you soon.
Yep. Thanks, Marino, for joining me. And yeah, we'll see everyone next time.
Thanks,
Bye-bye.
Peter. Bye.
Bye.